This is definitely on. Hi there, and welcome to this talk on Bluetooth best practices. My name is Richard Hyndman. I'm on the Android team, and I head up Android developer relations for Europe.
I'm Scout Sinclair Brody. I'm a product manager on the Android platform.
Hi, my name is Matthew Xie. I'm the Android tech lead for Bluetooth.
Okay, let's get this show on the road. So thank you all for coming today. I'm pretty sure that some of you out there must have suffered at the hands of this technology before. So, yeah, right, we all have. So thank you very much for coming along, being open-minded, and listening to what we have to say about Android on Bluetooth today. So, picture the scene. The year is, who can get the year? First person? Sorry? No? 1994. It's quite a tricky one. It's a bad year for Roman numerals, but the people over at Ericsson were sick and tired of having to reach around to the back of their computers to plug in their serial cables. They tried turning the computers round, but then the power buttons were on the wrong side. So like any good 90s innovative company, they decided to reinvent the whole system. And they came up with Bluetooth, as we know, for wirelessly connecting devices peer-to-peer over short ranges. Bluetooth's named after Harold Blartan Gormsen, Blartan being Bluetooth in English. He was a Danish king that united tribes together without the use of serial cables, so that was kind of handy. It's a good name for the technology. So you get the H from Harold, it's a rune, and the rune for B, put them together, and you get this bind rune that's the Bluetooth logo. We've had Bluetooth on Android, there he is, since version 1.0. That's my favorite animation in the whole deck. And we had Bluetooth 2.0 with the EDR stack, headset profile, handset profile, but no real APIs. So you can use classic Bluetooth to connect music to music players, mice to laptops, or mice with headphones to anything you want. But the point is, these things need to be able to talk to each other. They need to be able to discover each other. They need to be able to connect. And they need to be able to talk a common language. And for that, they're going to need a Bluetooth stack. So what's a Bluetooth stack? A Bluetooth stack is an implementation of the Bluetooth core specification. On the bottom of it, you've got the RF transceiver doing the actual wireless communications. Above that, you've got the baseband controlling the transceiver. Above that, you've got the protocol stack. Lots and lots of protocols all going into there so you can talk lots of different types of communication between any two Bluetooth devices. So this is a Bluetooth stack. And then on top of that, you have your Bluetooth profiles. Bluetooth profiles are definitions of Bluetooth profiles are definitions of which parts of the Bluetooth stack are required for doing each type of communication. Bluetooth profiles generally aren't tied in to any specific version of the stack. They're just definitions, which codecs you need, which parts of the stack you need. So when you see versions of Bluetooth, you're looking at versions of the core specification. Version 1, version 1.1, which was 802.15, the Bluetooth spec, was running about a megabit a second. Version 2 went up to about 3 megasecond. The little plus EDR means enhanced data rate is optional. Version 3, they claim, was around 24 megabits a second. Not sure I ever got that out of it. With the plus HS for plus high speed is an 802.11 Wi-Fi link, which brings us up to version 4. As I say, there have been many, many different Bluetooth stack implementations. In Android, we've had the BlueZ stack, powering AUSP devices, Samsung and HTC devices, Sony Xperias. We've also had the older Broadcom stack for some other HTC before ice cream sandwich devices. We've got a Motorola Bluetooth stack for a whole host of Motorola devices, and then some others as well. And of course, these are all compatible, but software has bugs in it. We know that software has bugs in it. So potentially you have to work around different issues, just little things here and there with all the different stacks. And whilst we've had all these different stacks, the Android APIs that have been available to developers and the Android Bluetooth functionality available to consumers has also been changing throughout the history of Bluetooth. Matt's just going to run through quickly the different APIs we've had on Bluetooth through the years.
Yeah, hi. I'm going to just go over Android Bluetooth versions, features, APIs a little quickly. So, as you know, Android loves desserts. So, we have you can see we have a real sweet Bluetooth. So starting at the beginning, we included Bluetooth. So Android 1.0, we have Bluetooth 2.0, with a headset and hands-free profile. So you can make a phone call using your Bluetooth headset or car key. Now, see Cupcake, we have a A2DP. You can stream music over Bluetooth. Next is Eclair. We have a Bluetooth 2.1 with IFCOM APIs. And we also added object push and the phone book profiles. Then with Fruel, voice dialing over Bluetooth. Honeycomb, we added APIs for profiles like A2DP and hands-free. Honeycomb also added hit and pan tethering, which is like you can connect your Bluetooth keyboard, mouse, gamepad, and typing with, instead of doing that on your phone. And pan, it's data tethering, so you can share your internet using Bluetooth. And SAS added health device profile, so you can stream your medical data real-time over Bluetooth. And then now it's Jelly Bean over Scott.
Okay. So as you may know, whoops, went back for a second. Forward again. Oh, too far. There we go. Okay, so as you may know, in 4.2 we introduced a new stack. We moved away from BlueZ to BlueDroid. This was a change that was made possible by a significant contribution to AOSP by Broadcom. There were, of course, some bumps in the road with this transition, for which we certainly apologize, but we felt that it was an important move on several levels. First, we wanted a stack that was optimized for embedded systems. Second, because of conflicting licensing models, we actually had to run BlueZ in its own process, which certainly had performance implications. And finally, we really felt that having stack development happen in AOSP would allow greater overall velocity in terms of adding features and adding stability and performance enhancements over time. So that brings us to a topic that many folks are interested in, which is Bluetooth Low Energy. Clearly, there's a lot of excitement about this technology, and I'm not sure that all of you are familiar with it, so I want to tell you a little bit about what it is and why it exists. Bluetooth, as it was originally conceived, was designed to allow devices with relatively large batteries so that charge frequently to interact with one another. As Rich mentioned, use cases for Bluetooth Classic typically involve streaming audio or other high bandwidth applications. However, the original specification was a little bit heavy for devices that have very small batteries or that you don't want to charge every day. So Bluetooth Low Energy was designed to work with devices in exactly this category, such as proximity tags that you can attach to your keys to help you find them, or pedometers, or fitness or medical sensors, or watches, or game controllers, remote controls. There are a whole host of possibilities with this technology. The goal is to let devices that run on small batteries like these go for years at a time without being recharged. The technology that we colloquially refer to as Bluetooth Low Energy is actually the official brand name of it, as propagated by the Bluetooth SIG, is Bluetooth Smart for devices that support just BLE, and Bluetooth Smart Ready for devices that support both BLE and Bluetooth Classic. So you might be wondering why I'm showing a Nexus 4 here, because up until this point, of course, we have not had support for Bluetooth Low Energy in the Android platform. But today we are excited to announce that when Android API version 18 is released in a couple of short months, the Nexus 4 and all future Nexus devices will support Bluetooth Low Energy with developer-facing APIs. So this means that your apps and your peripheral devices can take full advantage of this exciting technology. So in a couple of minutes, we're going to go through a couple of code examples, and you'll get a preview of the APIs for Bluetooth Low Energy. But I want to give you a bit of terminology first that will help you in understanding when we walk through those examples. First off, you should know that BLE is based on a specification called GATT, which is what your apps will actually interface with. GATT communicates using the attribute protocol, which, true to its name, transfers data in the form of attributes and operations on those attributes. The most basic type of attributes are descriptors and characteristics. A descriptor, also true to its name, is just a descriptive tag for another piece of data. A characteristic consists of a value and 0 or more descriptors associated with it. The Bluetooth SIG has adopted a number of standard characteristics for expressing such diverse information as the day of the week, or a blood glucose value, or a sensor's location on a bicycle. I mean, there are all sorts of crazy things in there. Characteristics can then be grouped together to form a service, which a BLE device can then advertise to other devices. A service spec states not only the characteristics that a GATT service makes available, but also which characteristics GATT clients can read, write, or receive notifications about. Note that when two BLE-enabled devices are communicating, either one can act as the client or the server. They can even switch off. It all depends on which one is actually making characteristics available to the other one. Moving up in the specification, the next bit here, there's the client and server. The next bit here is GATT profiles, which define how data provided by a service is to be exchanged between the GATT server and its clients. Profiles are defined with specific use cases in mind, but are generally designed to be flexible enough to accommodate multiple scenarios within a particular domain. As of right now, there are about 20 different ones for a bunch of different use cases. And as of Android API version 18, you will be able to implement these profiles in your apps, or future profiles that are released, or custom profiles that you want to define for your application. Back to Rich.
Thank you very much. Okay, so we had a quick look at the Bluetooth stack for Classic. Next to it now, we've got the Bluetooth stack for Low Energy as well. The points being here that at the bottom, you've got a Low Energy RF now. This is optimized instead of for streaming data like the Classic stack, just for bursting out these small attributes of data and then powering back down again. This is how Bluetooth Low Energy stays so low energy. And the protocol stack, instead of being this enormous array of protocols, is really focused on the one attribute profile. And on the profiles at the top, on the profiles at the top, instead of all the different profiles, we just got this GATT profile on the top. So the Bluetooth LE stack is a fraction of the size of the Bluetooth Classic stack. And because of the low energy RF, it needs a fraction of the size battery, and you get these devices, of course, that are a fraction of the cost and run for a lot longer. So as this talk's called Bluetooth Best Practices, we should have a look at some Bluetooth best practices. To demo this, we're going to run through an example of connecting a Bluetooth heart rate monitor to a Nexus 4. This is going to be, right now, the only place where you can see the Bluetooth LE APIs that we've created. So here we go. Although, to start with, you always need to check if the device has Bluetooth. When I was writing this slide, I was thinking, what devices don't have Bluetooth? I almost took the slide back out again, and then I thought, only the devices inside our ecosystem are CTS tested, and they're the only ones that we can guarantee that have Bluetooth on, so maybe there are non-Bluetooth devices. And then there's going to be things like Google TVs that also may not be Bluetooth devices. So to avoid horrific crashes, it's always worth checking if you have Bluetooth on the device. Matt's just going to run you through the code quickly.
Yeah, so let's talk about a little bit of code. To check whether there's a Bluetooth on your device or not, you check Bluetooth adapter. This is existing API. But you know, all the way you get it is you see using static method with Bluetooth adapter, get default adapter. If you look at this code, we are changing that. We're obsoleting that. Now we are doing this with Bluetooth manager. So you see context, get system service with Bluetooth service. And then from the manager, you get Bluetooth adapter. And now you check if that's now, then you don't have Bluetooth support in your platform.
OK, so we've got a device with Bluetooth. Of course, you're next going to need to check whether Bluetooth's turned on or off to avoid the next horrific crash.
Yeah, you do this by we provide API You do this by check from the adapter. You check whether it's enabled or not. If it's not enabled, you can send an intent to settings app to enable it. We don't have an API to enable it directly because we want full user awareness, so you cannot sneak Bluetooth on without users' knowledge.
Yeah, so you fire off the intent to get the Bluetooth setting screens up. Right, so now we're ready to connect the Bluetooth LE device to the phone. So we have a new flow for Bluetooth low energy. We start with a low energy scan, and that's going to put the device in scanning mode and look for any devices, any low energy devices that are currently advertising their presence and available for connections. You find the one that you want, you stop the scanning, and you connect to the device. Once you're connected, you discover the services of the device. In the case of a heart rate monitor, it's going to have the heart rate service. Then you can find the characteristics of the service. This is all about how the gap profile works. Characteristics of a heart rate service, one's definitely going to be the heart rate, the pulse. Another one could be the location of the pulse that it's checking on the body. Maybe you've got it around your wrist or around your chest or something. So you can then find the heart rate and then read it. You can either just read the attributes of the heart rate or register to get notifications about them. And here's the code for that.
Yeah, for first, you want to discover the BLE device. We provided a new API to do that in the Bluetooth adapter. This is like just for LE device. You do start LE scan. We have two API. One is just API with a callback. The other, you can pass in UUID filters to filter out only the device you are interested. And this API is callback based. We send out results through a callback, so you have to implement the LE scan callback API with the on LE scan. And there are three parameters we're going to call you. One is a device. That's the one you want to find out. And ISSI, which is the received signal strength. And the scan record is the advertisement data in byte array format. Okay, now if all you're interested is just the advertisement data, then you are done. But if you want to use the service hosted by the remote BLE device, you need to connect to it. You do this by Bluetooth device connect GATT. With this, you connect to the remote device. This is also callback based. If you look at the, there's a few callback functions because the connect call or discovery call or character read or write call are asynchronous. So you implement the callback function, and when there's results coming back, we will call the callback functions. Take example, after, like when you see...
Where were you? Sorry.
Right, yeah. So like say, when you see like discover a service, we will call back with on service discovered with the right status. And then you can say get services to get the service. Yeah, go next. So with a service is a list of Bluetooth GATT service. So you traverse the services. For each service, you can just go to look for characteristic, or you can use UUID to find out the service you are interested. And then same way, you go into each service and get characteristics, which is a list of Bluetooth GATT characteristic. With that, you can check UUIDs and look for the UUID you're interested. Like in this example, you can try to match the heart rate UUID and get that. And then you can also set notification. So we'll notify you if the characteristic changes. Okay, now back to Scott.
Okay, so there's your sneak peek at the BLE APIs for Android. This is an exciting technology, and we know that you're looking forward to working with it. There are a few other things that we think that you should bear in mind, though, as you're preparing to do so. First off, since BLE will be introduced in Android API version 18, you'll need a device running the next version of Android before you can take advantage of these APIs. However, once they are released, they will be covered by the compatibility program in the same way that Bluetooth Classic APIs are, which means that you can count on them being present in new and updated devices throughout the ecosystem. Next, we want you to know that the first version of these APIs have support for the BLE central role, but not the peripheral role. This means that you won't be able to have two Android devices talking to each other across BLE, at least not to begin with. Next, and speaking to the nature of the technology itself, please remember that Bluetooth is not a type of magic fairy dust that you can sprinkle on your existing apps and have them become suddenly more battery efficient. It is a different technology with very distinctly different use cases. And this is a common thing that I'll see, when in talking to people, they'll say, oh, and now we've got BLE. Everything's going to be much more battery efficient. I'm going to have much better battery life. Well, it doesn't exactly work that way. The data model for Bluetooth Low Energy is optimized for small incremental updates with a max theoretical throughput of 200 kilobits per second. Streaming audio or video is really not possible. However, if you're looking to send data over from a sensor of some sort, or if you're super forgetful and want to have BLE proximity tags attached to everything you own, Bluetooth Low Energy is going to be a fantastic option and definitely a more power-efficient way to go than classic Bluetooth.
Right, of course, whenever you're on a mobile OS, battery is always a concern. When you're running wireless communications on a mobile OS, it's even more of a concern. So just a couple of little battery tips for classic and LE. When you're scanning for devices, once you've found the device you're looking for, of course, tell the system that you found it and turn off the scanning. This also serves another purpose, because there's definitely with some of the stacks some conflicts when you're trying to make an RF comm connection with a device you've just found. And some people are nodding quite a lot. And if you're still discovering, so don't have discovery on while you try and make the connection. And you'll also save a bit of battery. Also, never loop on any RF functions. These are wireless devices. One might go out of range. It might lose its battery or something. So if you're trying to connect to a device and you fail, then just ask the user or do some intelligent logic about whether they want to reconnect again. Don't just sit there looping on the radio. We've seen it 1 or 2 times. And of course, it just depletes the battery, especially if you're in a background service and the user doesn't know what's going on, trying to reconnect to something that existed before. Also, don't reinvent the wheel. Android Beam is pretty established now. If you want to do a Bluetooth file transfer, for example, NFC is a great way for doing the Bluetooth handshake at the start for getting the details of the 2 devices. And with Android Beam, you just have to set the Beam push URIs or the create Beam URI callback, and you can make it so when the 2 devices touch, a large file is sent between the 2 of them. Android Beam will do the negotiation and send the file over Bluetooth for you. There's something to do with the RF comm APIs again as well. Our initial APIs listen using RF comm and create RF comm sockets, secure APIs. And that means that they need both devices to have a screen and I/O to be able to make the secure connection, because you need to do all the pin entry stuff. So if you try and make a secure connection, or if you just try and use these APIs and it fails, one of the reasons may be that the target device can't display a pin. If that's the case, go back to the insecure APIs at the bottom, create insecure and listen insecure, and it will create the connection much more simply. To be honest, most of the time you don't need to use the secure APIs. If you've got both devices in your hand, the chance of a man-in-the-middle attack is pretty slim. So you're going to save yourself a lot of bother inside your application if you just go with the insecure ones, because there's a lot less reasons why they would fail. One last thing. What would any good Bluetooth talk be without a final little teaser? I think it's a good point. We've got this whole new stack in there. We're announcing a few other things, so I'm very happy to say that also within API 18, in a few short months, we will be adding support for AVRCP 1.3. And to the people in the audience that means something to, they'll be quite happy about that. Terrence Eden will be very happy about that because he pings me about it every day. AVRCP 1.0 was in an earlier version of Android, and it meant you could connect your phone to your car stereo and do the remote control. With 1.3, we also add all the metadata as well. So you'll see your album art, you'll see your track numbers, track listings, album titles, that kind of thing as well. So of course, there has to be an API for that as well. And it's using an existing API, the Remote Control Client API. So anything that's already using a Remote Control Client, Google Music certainly does, a lot of apps have Remote Control Clients already, will automatically work for you, and your car stereo will get all the awesome information. If you want to have a look inside the API, have a look inside the media metadata retriever, and there's a whole load of different tags inside there that you can set inside on the API, things like the album art, things like that. And one final thing, make sure you always call clear on the metadata editor first, or you're going to mix your metadata up with whatever metadata was in there first, and it gets all a bit crazy. OK, back to Scout to wrap it up.
All right. So we've had a couple of exciting announcements, including the inclusion of Bluetooth Low Energy APIs in API version 18, along with AVRCP 1.3. We have office hours immediately following the session over in the Android sandbox that you're welcome to join. I think we actually have, we seem to have gone relatively quickly, so we've got some time for questions now as well. But of course, if you want to find out more about the Bluetooth APIs and anything relating to Android as always, you should definitely check out the developer website, and there's a specific link right there to the Bluetooth information. And let's have you step up to the mics if you have any questions.
Thank you very much.
Thank you.
Thank you.
All right. So it's hard to tell. I think we've got at least one question, so why don't you go ahead?
Hi, my name is Jimmy Buck. I'm from Stick and Find. I have a question about the new API for Bluetooth Low Energy. The first question is, will it support multiple devices connected at the same time? And the second question, will it support devices calling specific apps? So if the app is not running on the background, will you support this?
Okay, so let's take them one at a time. First was...
Will it be able to
multiple
connect
connections
to
at the same time?
We are, as essential, we can connect to multiple peripherals.
Okay, so if you're running in central mode, such as you're on the phone.
Correct.
Then
we
it
are
can connect
able
to
to do
multiple
that,
peripherals.
yes.
That's good.
Okay, and then the second.
The second question was regarding if a LE device can call a specific app that is not running.
So with these callback functions, even it's switched in the background, we will still call you back.
So if the app is not running and the LE device or the phone is on background, it could be on standby or the whole it's on standby, it's on the background, and a specific device that you've connected before, has been paired before, comes into range, will you allow to call a specific app?
I think your app, you have to implement a service so that if it's activity, if you are turned in the background, right, it's stopped. But if you have a service, then we'll call that.
So the scanning on the device isn't going to be scanning for new advertising devices that are coming past the whole time. The radio's not on scanning the whole time, so it won't know that a random device has just come into range, I believe. So you'd have to have a service that scans to try and find devices that are coming.
App on the background.
You'd still need to have a service in the background, and that would not be great for the battery, maybe.
Okay.
Right.
Thanks.
Okay, so let's alternate. So let's go on this side.
Hi, I'm William Quast. I have a question. I noticed you didn't mention any sort of backwards compatibility. Is there any hope of that? And do you think there's any prospects on backporting it? Is that even possible?
Do you want to take that as a...
Right, so all we're saying is that it's going to be API level 18 and above, and it'll be in the compatibility test suite. There's,
I mean, this is very common. You know, when a new API is introduced, it's for that API version. It doesn't necessarily go backwards in time.
Okay. So is there any, what are the, I've already started using the Motorola, the HTC, and the Samsung BLE library SDKs. Is it going to be?
That's definitely an option. Going forward, though, of course, all those devices will also, when they get to API 18, have to support the official framework set of BLE APIs. So if you do want to support those current SDKs that are out there, that's absolutely fine. As always with Android, it's open. But going forward, yeah, you just have to support this one set of APIs, and it will make your life a lot easier.
Okay.
To support multiple devices connected at the same time, when the app is in the background, and how do I know which? Like in a proximity case, there are multiple Bluetooth, let's say, tags, and you know, how can I distinguish whether a particular, you know, few tags are of interest to me that are mine? There could be other tags which are not mine. So how do I take care of such kind of situation?
Under the assumption that you've encountered these tags before.
Yeah.
Okay.
Yeah.
Is there an association in Bluetooth LE?
Well, you can associate inside your application with the ID from the tag. So the first time you get the tag, you can say, this is my keys. To, inside your app, it says it's found the tag, and you could give it a name inside your app if you wanted. But each BLE device is a unique ID that you'll be able to reference again.
So
when
it's
you
completely application based, right? So it's not anything to do with the stack itself?
No.
Or the OS?
Entirely up to the application.
Right, okay.
Hi, my name is Albert. What LE profiles will be supported when API 18 comes out?
So right now we support, there's GATT, there's support for GATT, and you can implement support for GATT profiles in your application.
So you're expecting LE profiles like heart rate monitors and hit over GATT will be distributed over the
They
Google
all run
Play
over
Store?
GATT, yep.
Yes, they all run over GATT in Bluetooth Low Energy.
And they can be distributed over the Google Play Store?
Yeah, it's part of the app. It's part of your app. Yeah.
Okay. Is GATT server will be supported?
Yeah, we support we also open up API to support GATT server. Yes.
GATT server. How about GATT over basic rate over EDR?
Can you say it again? What?
GATT on Bluetooth.
GATT over basic rate over EDR. So in the Bluetooth specification, GATT could run over low energy protocol and also could run over basic rate EDR.
Yeah, we also support that. Yes. Yeah. So if it's on the basic rate, the API will still work. Yes. Yeah.
Oh, can you turn the mic back on? Go ahead. No, you should be fine. I was asking them, the tech folks, to.
Oh, hello.
Yeah, you're good.
Oh, I didn't get the answer. I'm sorry.
Oh, my answer is the same API will work in that case too, like GATT over basic rate.
And you mentioned earlier that the peripheral role is not supported.
The peripheral role is not implemented in Android for API version 18 at this point, no.
How about the observer role and the advertiser role? So in the GAP specification, there's 4 roles: the central, peripheral, observer, and advertiser. Will the other 2 roles are supported as well?
It's you're talking about the broadcaster,
The broadcaster,
observer, right?
Yeah, observer.
No broadcaster. Observer, yes.
No broadcaster.
At this point, at the API.
We're still
18,
making these APIs.
At API 18, no. We don't do advertisement. We don't do advertisement. We do scanning for the advertisement. So we are in the central role basically. The broadcaster role, the observer role you're talking about, doesn't really apply to us because we have TX and IX. We have both TX and IX. So
it sounds like.
Answer your question?
Maybe this is something that we can continue during office hours, if that's okay. Can you make it to office hours and we can? Okay.
So in short, we do Central. That's it. With Central, we can scan advertisement. So you have observer there, supported in default too. So, but no broadcaster or peripheral. at this point for API 18.
Okay, so
Thank you.
Thanks. Let's move over here.
Hi, my name is Diego. I work for a company that does multiple mobile platforms. Is this going to be available? Is this going to work also with other platforms like iOS or Windows phones that already support Bluetooth 4.0?
Well, so it depends. I'm actually not familiar whether or not those devices support the peripheral role, because in Android API version 18, we only support the central role. So if they can do peripheral, then we can talk to them, correct? But if they only do central as well, then as of API 18, no, you won't be able to talk over BLE with the devices.
Okay.
Basically, you need something that can be in peripheral mode.
Okay, thanks.
Hello, I was curious about aptX or aptX, higher dynamic range Bluetooth streaming audio.
Right.
Is that going to be supported in AOSP, or is that just relegated to Samsung, HTC, and others that pay a license fee? I'm just curious.
So as far as I know, that's not something that we have working for this next version. And in general, we don't comment on things that are happening after that. So. Definitely stop by office hours if, to talk about it and make sure that we understand sort of your use cases and what you envision this being useful for, because it can be useful for us in sort of prioritizing what features and what aspects of the spec we go for next. But at this point, we won't comment on things like that. Sorry. All right, I guess one more over here, and then we head to office hours.
This is just a curiosity. The iOS Bluetooth stack rotates MAC addresses every 15 minutes. Does the Android stack do anything like that? It's a privacy feature, apparently.
I think we do that, yes.
Okay, cool. And just curious, what type of range have you guys seen on Android to peripheral? Like, how many feet?
Have you tried that? Mine works from here to here quite well.
6 inches? 12 inches?
More than that. I think it's.
I mean, obviously, it depends on the device.
Yeah, it depends on device. About 10 meters, I would say.
So one last question. The RSSI, is that going to be normalized across devices? So if I have 2 devices, like a Samsung and an HTC, and they both report, say, an RSSI of 85, would they be about the same distance? Or is it calibrated per device or per radio vendor or something?
That's a good question. I think we are. It's calibrated.
Cool. That would be great for the CTS or whatever to make sure that those are consistent, because otherwise we'd have to check it manually. Thank you.
Yeah, makes sense.
Thank you.
All right, on to office hours. Thank you all
All
for
right,
your
yeah,
time.
the office hours is on the 3rd floor at the back at the Android area. Thanks very much.
Indeed.
Thank you.